In this module, I'm going to talk to you about querying data using the select statement. So I think I've said this a number of times already in the course if you've listened to the earlier modules, but I'm going to say it again. A select statement is really a question, right? It is the translation of a question you have about your data into correct, valid SQL, into an SQL statement. So what are some of the types of questions that we might ask? We might ask, who are all my contacts? Show me a list of all of my contacts. More likely, we're going to want to do some sort of restriction. A restriction could be, who are all my contacts with the first name of John? Right? That would allow you to reduce the set of overall contacts, and rather than having to look through and finding the name of John, you can just find who are all those contacts, right? These are things that we're used to doing, for example, in your contacts database on your phone, right? You can scroll through all of your contacts, or you can put in a search term at the top. You can do this against an SQL database as well. In fact, it's more than likely that, most contact databases on your phone or your desktop are built on top of a database and are executing some sort of SQL. Now, there are other types of SQL statements as well, like how many contacts do I have? That's another important, potentially useful piece of data. It doesn't have to do with the actual rows of data, the values in each row for each column, but it has to do with what kind of overall sort of roll-ups or aggregations can I find out about my data? Those are also the kinds of questions that you might ask. So let's start with a simple query. The simplest query is going to have the select keyword and then a select list. Now, in this case, the select list is the string hello and the string world. Now, this may look like a very odd kind of query. We're not actually getting any data from a database in this case. What we're doing is we're using the database query to return to us a row with two columns. The value in column 1 will be hello, and the value in column 2 will be world. Now, again, the select list is part of the select clause, right? So the select clause is what we need to have a valid select statement, and that is made up of the select keyword and a select list. Now, as I said, you may be confused by why would I ever want to return a string. It is actually very useful to be able to return constant values in some cases. If, for example, there are values that you need in an output, let's say for a spreadsheet or for another program, that those values are not actually in the data that you are querying, you can sort of interject those items. That's sort of a more advanced kind of thing, but it is something that is useful, and it's good to know that the most basic select statement you can execute doesn't actually involve going against any data at all. Okay, I'm in SQL Workbench, and I have created my database, the contacts database, and I'm in an open new SQL tab for executing queries. So I'm going to start typing in some SQL. So I'm going to say select hello, comma, world. And I'm going to hit this button to execute that. Here, right below the SQL, is the results grid. And the results grid, you can see that my result is hello and world. Okay? So this is the super most basic SQL query ever. Now, one thing I want to show you here is that if you want to execute just part of a file that you have open inside of MySQL Workbench, you can select, highlight those characters that you want to execute, and then press the execute button. Now, notice that I get an error message. It says, you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server to make sure that you're doing everything correct. That's what it's basically saying. And so select by itself is not a valid command, right? We need to select something, right? We need a select list. So the select list, in contrast to the last slide, is most of the time, vast majority of the time, going to contain names of columns from the table or tables that you would like to get data from. Now, once you have a list of columns, then you're required to have a from clause, right? In the last slide, we didn't need a from clause because there were no column names. Once you have column names, the table name is required in the from clause. Now, in the select list, after every column of data, you're going to need a comma, right? So you separate each column that you'd like with a comma, except no comma after the last column, right? When you go from the select list to the from clause, there's just a space, right? But as always, we have the semicolon at the end of every valid SQL statement. So now let's look at a select statement visually, right? We're going to have the select keyword, column name, followed by a comma, column name, and since this is going to be the last column name, no comma, from, because now we have column names, we're required to have a from clause that specifies the name of the table that the columns come from, right? So if we translate this into a real statement, we're going to have a select statement, a column name, from, right, the keyword, and then the table name, like person. And then, of course, the semicolon at the end, right? So again, column names, table names, these are identifiers. Select and from are keywords. Putting these two together will allow you, as in this case, to have a valid SQL statement. In this case, one that will return every row in the person table, and it will return just the first name and the last name columns. Now, sometimes when you look at a table and you're going to write a select statement, you might think, wow, there's a lot of column names that I'm going to have to write down. And there is a way to not have to write down every column that you want to get. That's by using the asterisk or the star. This is the wildcard select list, right? If I say select star from table name, that's going to give me all of the columns. And that might seem like a really good thing. This is not a good thing. Using star or the asterisk in a select statement is considered a very bad practice. The reason this is a bad practice is if the application that's getting back your data has to look at the different columns, what happens if the database updates those columns or adds a column? Well, now the database application could be caught in a weird situation. It's much better to be explicit about the names of the columns in your select list. It will benefit you greatly, even if you maybe don't understand now completely why, if you're new to SQL. But just to warn you, if you submit SQL statements with star in it to any sort of code review, or maybe you have to show it to the database administrator before the database administrator will let you run that query, nobody's going to like this, right? Everybody is going to say, hey, could you use column names instead? Okay. So the from clause is going to at least define the table that you want to query. Okay. It is possible to query multiple tables, as I've said. We're going to cover that later in the course, however. So for right now, we're going to stick with a single table name in the from clause. Now, a good practice is, instead of saying first name, last name from person, semicolon, it's a good idea to qualify every column name in your select list with the table name. So if we were going to do that in this case, first name would turn into person dot first name. Person dot is the qualification for the column first name, where person is the table, and then dot indicates the relationship, right? The column is a child of person. Same thing for last name. And now we can say from person, add the semicolon, okay? So this is a good practice, right? It's a good practice to always table qualify the names of your columns. Some databases will run this query faster when you have qualified the name of the column. But certainly for one thing, I think it makes the SQL statement much easier to read. The select list is much clearer. And again, in this simple case, it may not seem like that's such a big deal. But as we get into more complex queries, as we get into multi-table queries, always qualifying the column names helps you to be able to disambiguate which columns are from which table. Okay, so again, good practice. You should do this. Now, you may be already thinking to yourself or have thought to yourself, wow, that's going to be a lot of typing. Well, there's a couple reasons why it doesn't end up ever being a lot of typing. One reason is that most tools like SQL Workbench for MySQL, or the tools that help you to connect to Oracle, or the tools that help you to connect to SQL Server, almost always have some sort of statement completion that allows you to only type in like the first two characters of a table name, and then it will fill the rest out for you automatically. Even if you don't have that capability, there is a way to make this less painful than typing out person dot, right? Person dot first name. So that's 1, 2, 3, 4, 5, 6, 7 extra characters that you have to type in, right? What you can do is you can alias the table name. So you can say person P, where P is the alias that you're giving to the person table. As you can imagine, that allows you to say P dot first name, P dot last name, right? And then of course, don't forget the semicolon at the end. This is the way that you can simplify that task of always qualifying the column names with the table names, is that even in the simple case like this, by aliasing the table name, you've saved yourself 14 characters of typing, and it actually is a little bit easier to read, because in your mind you can just do a replacement of, okay, P is the person table, so I can sort of read this as select person dot first name, comma, person dot last name from person, right? And P is just this nice convenient alias that helps you to write less characters and keep your SQL statement less cluttered, but still qualify all of the columns in your query. Again, once you get into multi-table queries, this will become even more important, but even in this simple case, it does make a difference. And again, best practice, right? Best practice is to not only qualify all the column names, but to alias each of the table names. Again, helps you simplify the query, keeps it much cleaner and much easier to read. Okay, so I'm ready to do the next demo. Now, remember our first demo, our simple select hello and select world. I'm going to go ahead and comment that out in this file. That's another neat thing that you can do with SQL files, is you can comment out sections of it. Now remember I said that you can highlight a section of a SQL file and just execute that. And you can do that regardless of whether that section, that selected section, is inside of comments or not. So that's a good way to sort of have a file with multiple SQL statements if you want to be able to execute them, but not always execute all of them at once. So the thing that we were talking about here is aliasing. And aliasing allows you to do things like this, right? I can say, select hello as first word, select world as second word. And now when I execute this, notice that first word and second word become the column names, right? So this is just like aliasing the column names in the select list if those items were from a table, like select P dot person first name as first name from person P. So I'm going to highlight that portion of my file and execute. And notice it tells me it doesn't know where to find person, right? It doesn't know how to find that entity. And the reason is because my particular open session here isn't tied to a particular database. So I'm going to go ahead and use this keyword. I'm going to say use contacts. And putting the use contacts at the top of my SQL statement means that all of the other statements after that will be in the context of that database. Another way to do that in SQL Workbench is to right-click on the database, and you can basically then say, you know, I want a new SQL tab for that database, okay? This is another way to do that. I'm going to go ahead and execute this again. And so you see here I get first names, right? I get John, Shannon, Fritz, and John. And that means that there are 2 Johns inside of my person table. Now, you may note that in the slides, I'm not using person underscore. I'm just using first name, last name. A simple reason for that is that person underscore first name underscore name doesn't fit very well on the slide. Also, kind of keep you on your toes if you are following along with the slides and then you're using the exercise files. You're going to have to basically hand type the SQL because you can't copy and paste it out of the slides. So those are the 2 reasons that I'm using the longer column name inside of the actual files. Now, all of the queries that we've done so far have returned all of the columns from the table. Although you will sometimes run such a query, it is fairly unusual. Most of the time, what you want is some subset of the data, right? You want to constrain the rows that get returned to your data set from the SQL statement. And so there are really 2 ways to constrain the number of results. One way is to add a where clause to your select statement. The where clause we're going to cover in detail in the next module. So I'm going to cover the other way that we can constrain the number of results, and that's by using the distinct qualifier. So not distinct is, what are all the first names of all the people I know? Here's our question. Here's our query. Select P.firstname from person P, semicolon. So this query, this select statement, returns a complete set of all of the first names from the person table. So not distinct, right? All of the names. So let's say that that particular result returns John, John, Fritz, Shannon, Jason, Jason, Brian, Brian. So this means I have 2 people in my contacts in that person table who have the first name of John, 1 Fritz, 1 Shannon, 2 Jasons, and 2 Brians. Okay, so a pretty sort of typical distribution of names. If I said distinct, that is, if I said, what are all the unique first names of the people I know? This is one way to reduce the result set. The distinct keyword goes after the select statement, before the select list, and then the rest of the query is the same, right? So reading the query is select distinct person.firstname from person, P, right? Where P, we are aliasing to the table name person. This result set would be different. This result set would just be John, Fritz, Shannon, Jason, Brian, right? The fact that there are 2 Johns, 2 Jasons, and 2 Brians isn't of consequence to this particular question and thus to this particular query, right? So the distinct keyword will take all of the values that your result set would have returned, and it will find all of those values that are distinct and only return you one row for each of those distinct values, right? So this is a way to reduce your result set by saying, I don't want all of the items from that table. I just want all of the distinct items from that table. And this is sometimes a useful question to ask, right? Think about a sales table. What are all the unique countries that we have sales to, right? Select distinct country name, or whatever the way that the country is formulated inside of that database, would give you a breakdown of all of the countries that you've ever sold items to. And that can be a useful piece of business information. It may inform the business on, hey, we've got some sales over here in this country. Maybe we need to beef up the sales force in that country, right? Again, these are just examples of the way that getting the distinct list of values can sometimes really be the question that you want to ask. Okay, so let's talk about distinct and not distinct. So not distinct is the default. And when I go ahead and execute this query again, notice I get first name, John, Shannon, Fritz, and John. Right? Why does it look that way? Well, if I go look at all of the data in the table, I'll go to the person table, and I can right click on it and say select rows. It's going to show me all the data that's inside of the person table. And you notice that there are 2 people with the first name of John. So that explains why over here, I'm saying person first name, I'm getting John, Shannon, Fritz, John. Because if I look at the table, I've got John, Shannon, Fritz, John. Okay. And this does a select star. Again, this is okay for testing, but make sure to stay away from select star when you're actually doing SQL for a real project. So if I go back over here, if I want just the distinct person names, I'll just type in distinct. And if I type in distinct person first name, that's going to only give me 3 results because the name John appears twice. Now, you have to be careful with distinct because if I say distinct p.person first name and then p.person last name, and notice SQL Workbench brings up a list of all the columns, and I can just select the one I want. That makes typing in longer column names much easier. I'm going to go ahead and execute this script. Notice now it gives me 1, 2, 3, 4 rows again. And even though I have the distinct qualifier here, it's giving me distinct for the combination of columns in the select list, right? Not necessarily the column that is first, that is nearest to the distinct. So the distinct applies to all of the columns in the column list, not just the first one.